Our next presentation is going to be a team of folks from Samsung. And we're going to have Wasuk Go, who's Executive VP of Memory for Samsung, where he oversees the commercialization of flash storage products that include mobile memory devices like eMMC and UFS, as well as the client, server, and enterprise class SSDs. Wasuk Go joined Samsung back in 1997 as a system-on-a-chip design engineer, focused on development of networking and storage controllers. And while working on flash storage products, he pioneered the world's first UFS products. He also spearheaded the creation of high-performance NVMe SSD controllers for data centers. And more recently, he's been on the forefront of developing new flash storage technologies that contribute to the innovations that Samsung's smart SSDs and their flash-based CXL memory modules. He holds a bachelor's and a master's degree in computer science from Sogang University. With him is also going to be Dae-Hoon, VP of Memory and for Samsung. Dae-Hoon Lim joined Samsung in 2023, serves as their VP of Memory for leading HBM I/O design and VP of Technology. And prior to Samsung, he was with the IBM ASIC group working on high-speed serial link design. He was also with Nokia's network infrastructure and designed silicon photonic transceivers as a distinguished member of their technical staff. His expertise includes high-speed memory interface circuits, signal and power integrity, and optical transceivers. He received his degree in electrical engineering from Seoul National University, master's and PhD in electrical engineering and computer science from MIT. And in 2017, he was recognized as the author of the most frequently cited paper in the history of VLSI Symposium. Please join me in welcoming these three gentlemen. Come on up from Samsung.
Good afternoon. My name is Dae-Hoon Lim, and I'm from a DRAM development team at Samsung Electronics. It is an honor to be here at FMS to share how Samsung is preparing to meet the growing demand across the entire memory and storage landscape, in step with the rapid advancement in AI that is shaping our industry. AI is already deeply embedded in our daily lives, and it continues to evolve rapidly. The technology is expected to progress from generative AI to agentic AI and eventually to physical AI. By adding reasoning to LLMs, agentic AI enables systems to autonomously set goals, plan, and act without human input. On top of the requirement of generative AI, agentic AI must store multiple states and utilize tools without noticeable increase in latency. As a result, the trend of explosive growth in bandwidth and capacity will continue. As AI agents gain momentum, the volume of global data and the demand for compute to process that data are growing at unprecedented rate. However, with the latency remaining limited, the bandwidth requirements are rising exponentially, while the power consumption of existing systems has already reached its threshold. This shift underscores the growing need for data-centric computing. In particular, during the agentic and reasoning stage of AI processing, data must be retained longer to derive optimal results. This leads to the sharp increase in memory capacity requirement as well. To meet the evolving demand, memory and storage are becoming more advanced, specialized, and essential to the next generation intelligent infrastructure. The traditional memory hierarchy is being restructured to better support rapidly changing application and customer needs. By looking at the industry through the lens of memory landscape, we can clearly understand the distinct role and evolution of each technology area. In computing servers, HBM is required to deliver high performance, high bandwidth, and lower latency, and greater capacity, all at once. To address DRAM's capacity limits, CXL memory expanders are emerging as promising solutions. While still in its early stage, CXL is already redefining server architecture, enabling scalable and flexible memory expansion independent of compute. Meanwhile, TLC-based storage, located closer to the compute resource, must deliver higher performance, while QLC-based storage plays a key role in efficiently storing large-scale data sets. First of all, let's explore HBM, a key enabler for high-performance AI computing. Initially, HBM was designed to improve the total bandwidth through a massively parallel architecture rather than focusing on perpend speed. However, with the rise of generative AI, the need for dramatic increase in bandwidth emerged. At the same time, implementing even greater parallelism has led to an increased power consumption and raising a serious thermal concerns. To address this, the customers are actively seeking ways to optimize power usage, which has led to a strong demand for a new paradigm. The first point to highlight in this chart is energy efficiency. DRAM has consistently improved in energy efficiency through process scaling. However, with HBM3 and 3E, we begin to see the plateau and the further gain becomes very marginal. To overcome this, HBM4 adopted the cutting-edge logic process node and resulting in a significant improvement in energy efficiency, and a trend expected to continue into HBM4E. On the other hand, without a fundamental change in architecture, the power consumption will still continue to rise and leading to a thermal management challenges or even system-level performance degradation due to thermal throttling. Meanwhile, the demand for even higher memory bandwidth shows no sign of slowing down. This indicates the need for the new paradigm beyond HBM4E. Customers are now exploring various approaches to enhance HBM access efficiency, which could play a key role in shaping the future memory landscape. Let's briefly talk about HBM4. HBM4 adapted 2K I/O, which is doubling the count of HBM3 and 3E. To improve the power efficiency, despite the increased I/O count, HBM4 employs a base die built on the FinFET-based advanced logic process. As a result, HBM4 delivers 36 gigabytes of capacity and energy efficiency of 2.5 picojoule per bit. And the next generation, HBM4E, will offer even greater capacity and speed, along with the further improvement in energy efficiency. The demand for higher memory bandwidth, driven by increasingly complex AI algorithms and applications, is expected to accelerate even further. Now, customers are now looking for differentiated, power-efficient solutions optimized for their own workload requirements. These evolving needs are shaping the direction of the new next-generation HBM development. However, from the perspective of DRAM supplier, it is very difficult to accommodate all these varied requirements within a single standard product. This has led to the emergence of a new paradigm, which is custom HBM. By applying the advanced logic process that we mentioned earlier, Samsung has been able to secure approximately 25% of additional gray area within the JEDEC standard base die. This added flexibility enables us to offer customized base die designed to meet each customer's specific needs. Customization comes in various forms. Customers can leverage Samsung's IP and design process to build power-efficient AI system engineered for their own technical capability and product characteristics. Additionally, by integrating extra functionalities such as memory controller directly into the base die using our provided IPs, they can even further enhance system-level power efficiency. With custom HBM, we are basically paving the way to near memory architecture optimization and capacity scaling that you need. Samsung offers a comprehensive turnkey model from base die design with IP, wafer testing, FPGA delivery, and advanced packaging. We also provide flexible and collaborative engagement model that can extend beyond our own process technology whenever our customer needs it. We fully understand where we stand, both in history of memory and in the current HBM market. Once the famous former CEO of IBM, Lou Gerstner, asked, "Why can elephant dance?" And he changed the giant. Today, we are redefining what it means to lead by making custom HBM Samsung's dance floor for the future. At the heart of it all, our goal remains clear: to deliver the most optimized solution tailored to our customers' ever-evolving needs. Samsung is leading a major transition in HBM die stacking from TSV to HCV. Today's HBM product relies on thermal compression bonding, which uses physical bumps for chip-to-chip connection, this approach creates spacing between dies and requires gap-fill material, both of which limits the number of dies that can be stacked and confine thermal resistance, which is a critical factor for heat dissipation. HCV enables gapless stacking through direct copper pad-to-pad interconnection, eliminating the need for gap-fill material. This allows for a higher number of die stacks and significantly improves the thermal resistance. In addition, HCV supports finer TSV pitch, enabling greater TSV density, which in turn enhances both signal integrity and power delivery. Now, I'd like to shift our focus to CXL, an emerging interconnect standard shaping the future of memory expansion. As LLM grows, GPU alone face memory limitation, requiring more device or costly upgrades. CXL enables efficient memory expansion, allowing larger models to run on existing hardware and help reducing the cost. Samsung has led the CXL memory space since launching the first product in 2021, driving the ecosystem growth and adoption. With the CXL market set to expand beyond 2025, the CMMD 3.1 era will bring full feature support, including processing near memory engine capability. We are now currently mass producing DDR-based CXL 2.0 products, and in the second half of this year, we'll introduce our CMMD products supporting both CXL 3.1 and PCIe Gen6. Samsung's CXL memory solution will make memory expansion easier and faster while ensuring reliable data transmission across the system. Starting with CXL 3.0, we are preparing to support real-time memory sharing across the multiple servers, taking flexibility and scalability to the next level of the future data center environment. With CXL-based memory pooling, we can allocate memory as needed, improving server scalability while reducing overall system cost. This approach enables more efficient resource utilization across the workloads. We're also developing CMM-DC, a CXL memory solution with a processing memory engine that brings compute closer to the memory. By embedding the accelerator logic into CXL controller, it improves the performance and energy efficiency and overcomes PCIe bottlenecks and enhances scalability and TCO. Now let's move to storage. Please welcome Mr. Hwa-Seok Oh, who introduced how storage ensures AI gets the data it needs when it needs it. Please join me giving him a warm round of applause.
Thank you for the introduction. It's an honor to be back at FMS this year, and once again, to share the latest updates on Samsung's storage solutions. The AI era calls for massive GPU-based infrastructure to support increasingly complex workloads. Within AI infrastructure, storage is a critical component. TLC-based storage, located closer to computing resources, is under constant demand for higher sustained performance to support GPU processing. Meanwhile, QLC-based storage, positioned further from compute node, is expected to deliver higher capacity, enabling more data to be stored within the same rack footprint to support large-scale data sets. Referring back to the memory landscape, conventional storage is evolving in line with the changing storage requirements of the AI era, with TLC SSDs offering lower latency and QLC SSDs offering more capacity, while also facing challenges in terms of power and security. Ongoing innovation is essential to address these challenges and to keep pace with AI era demands. Today, I'd like to walk you through Samsung's solutions and vision across 4 key areas: high performance, high capacity, thermal control, and security. Let's begin by looking at high performance. PCIe interface transitions are accelerating, and performance doubles with every generation. PCIe 5 technology is becoming critical due to signal interference and loss at high speeds. NAND speed does not increase linearly with PCIe, so NAND controller should be designed to maximize I/O efficiency. In particular, controller architectures should be evolved to combine both scale-up and scale-out approaches. PCIe Gen6 products are just around the corner, with Gen7 and Gen8 not far behind. Samsung is set to launch PM1763, a PCIe Gen6 SSD, leveraging high-speed NAND I/O early next year. Despite operating within a 25-watt power limit, it delivers maximum interface performance. Compared to the previous generation, it offers 2 times higher performance and 1.6 times better power efficiency. Let's talk about 5 issues with high-speed PCIe. As PCIe evolves to higher speeds, crosstalk in off-chip interconnects degrades. Signal interference will worsen in PCIe Gen7 from all the components in server environments. Samsung is the first to analyze PAM4 SI margin across all entire end-to-end PCIe Gen7 system channel. And we found solutions that improve signal quality by 75%, and the connector is the most critical component to signal integrity. I believe close collaboration with component vendors is essential to the success of PCIe Gen7. To meet the growing demand for high-capacity storage in the AI era, a form factor transformation is essential. This year, we introduced the 128 terabyte U.2 drive with a 2T thickness. In 2026 and 2028, we plan to launch even thinner 1T EDSF drives, delivering two 56 terabyte on Gen5 and 512 terabyte on Gen6. EDSFF offers a thin, wide, and dense design, enabling slim yet high-capacity devices with improved power efficiency and storage density. What makes this ultra-high capacity storage possible is our advanced 32-die packaging technology. Samsung is continuously developing technologies to maximize density per package. Now, let's explore the evolution of thermal control technology. As rack density and compute intensity increase, power consumption is also rising, demanding more efficient cooling solutions than traditional air cooling. We are now transitioning from indirect to direct cooling. Liquid cooling represents the first step in this transformation. To maximize the benefit of direct cooling, high capacity yet thin form factors are essential. For example, we reduce the thickness of our E1.S 8 terabyte SSD from 15T to 9.5T, which is now being prepared for integration into the next generation GPU system. Samsung continues to explore optimal form factor designs for liquid cooling, with a particular focus on minimizing thermal resistance between the cold plate and the SSD enclosure through various thermal design techniques. Looking ahead, immersion cooling is expected to become the next generation solution. Samsung has ensured coolant compatibility for both one-phase and two-phase systems built on internal database MBOM, and we established a dedicated evaluation infrastructure. We've already leveraged these capabilities to develop a Gen5 E1.S SSD optimized for immersion cooling environments. Security, an issue we can't afford to overlook. As our AI models are increasingly used for training and inference, the need to protect data privacy and ensure trust has become more critical than ever. Confidential computing addresses this challenge by keeping data secure during processing, ensuring confidentiality and integrity in cloud and external environments. Its primary goal is to protect data in use, complementing existing protections for data at rest, and data in transit, completing the end-to-end data security framework. Confidential SSDs play a critical role in enabling end-to-end confidential computing. To achieve this, several layers of security must work together. SPDN ensures mutual authentication between the host and SSD, verifying device identity and integrity, and establishing an encrypted communication channel. IDE enables packet-level encryption between the host and SSD, protecting data in transit. On top of these secure sessions, TDISP creates a one-to-one mapping between the host trusted virtual machine and the SSD's virtual function. This ensures that all data exchanges are encrypted and integrity protected throughout execution. Only when all these elements, SPDM, IDE, and TDISP, are properly implemented, we can deliver full support for confidential computing at the storage level. Samsung has been at the forefront of this integrating advanced security technologies directly into our storage devices. SPDM has been implemented since PM 1743. PQC has been supported since PM 1753 in preparation for the post-quantum era, where conventional cryptographic algorithms may be compromised. Our upcoming PM93 and PM1763 will support IDE, and next generation products will incorporate TDISP support to complete the confidential computing framework at the storage level. Let's take another look at memory landscape. You will see a large empty space between the memory area and the conventional storage. Due to retrieval augmented generation in agentic AI, AI inference requires rapid and repeated access to small chunk of data. This means that storage must excel at handling small size random I/O, while also delivering high throughput and low latency, both critical for real-time response. To meet these needs, we believe a new tier of storage is required. And we are calling it memory class storage. From a system perspective, memory class storage retains the essence of traditional storage, but delivers much faster latency approaching that of memory. An example of what we are calling memory class storage is SSDs for GPU-initiated direct storage. To minimize bottlenecks within computing servers, Samsung believes that a new class of media that can outperform conventional TLC SSDs is needed, and we are actively researching ZNAND. Targeting GIDS, our PCIe Gen5 class ZNAND will deliver performance that is beyond the capabilities of previous generations of ZNAND. We expect the throughput of Samsung's third ZNAND to far exceed industry requirements, maximizing power efficiency and delivering ultra-high performance. As the need for new types of storage based on ZNAND continues to evolve, we look forward to shaping the future of next-generation solutions together with you. Some of the technologies described above are reflected in our upcoming products. So be sure to visit our booth to get a sneak peek. With this advancement in memory and storage, we are not just managing more data. We are unlocking the full potential of AI. This will shape a world that's not only more productive and convenient, but also more inspiring, opening doors to possibilities we once only dreamed of. At Samsung, we will continue pushing the limits of technology to deliver the right solutions at the right time with the right quality to empower the future we envision together. With our customers and partners, we will unlock new and infinite possibilities ahead. Thank you sincerely for your attention. We look forward to your continued support as we drive the next wave of innovation. Thank you.